talk about factoring, and we're going to talk about factoring quadratic trinomials, three-term expressions, and we're going to do simple trinomials as well as complex trinomials. Simple really means that the leading number, or a, is equal to 1. In this trinomial here, I hope that you can agree with me that the leading term does have 1 for a coefficient. So it's a very simple way to factor it, and what we do is we use the product sum method. The product is really the number that's a constant at the end. So in this case, the product is 12. The sum is the coefficient of the middle term, which in this case is positive 7. So there we go. We've got our product and our sum. The way we do this is we look at all the numbers that multiply to our product, which is 12. So I can write down my list. 1 and 12 will multiply to 12, 2 and 6, and also 3 and 4. All of these pairs will multiply to 12. Only one of them will add to my sum, and in this case that sum is positive 7. So I hope you agree with me that 3 and 4 is the correct pair that will add up to 7 and multiply to 12. Once I figure out my two numbers, 4 and 3, the only other thing that I have to do is create my factored brackets. The first term is always x plus 4, because that was my first number, and the second bracket is x plus 3. So literally the two numbers that multiply to 12 and add to 7 are just placed in my factored bracket, and I'm done. That's it. And you can tell why this is called simple. It literally takes one step and you're done, as long as you know how to do the product and sum method. That's usually what this method is actually called. Instead of saying factoring simple trinomials, we often call it product sum method. Now what happens when a, or that leading number, is not equal to 1? In this case, it's equal to 3. Well, we kind of start off the same, but we've got to do several additional steps, altogether 6 steps in order to factor this. So I hope you've got your pencils out. We're going to factor it. Bear with me, write stuff down, and let's get to factoring. So this method is called complex trinomial, so it really just means that the leading number is not 1. The method is also called decomposition, and you'll see why. I'm just going to write decomp. And how do we go about doing it? Well, the method actually starts off quite similarly to product sum. Step 1 is multiply the leading coefficient and the constant term. So the leading coefficient is 3. The constant term is the number in the back. And you're going to multiply them. So that's 3 times 8, which is 24. And then we go about and start to figure out factors of 24. So that's basically the same thing as product and sum method, right? So we are looking at what two numbers will give me a product of 24. And here's my list: 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then I look at the middle term. Coefficient is plus 10. And again, I've got to do my sum. One of these pairs is going to be the pair that adds up to 10. And I hope that you agree with me. It's 4 and 6. So that is my two numbers. Now, in the previous example, I literally would have been done if I figured out this product sum and my pair of numbers. In this case, I'm actually not. So I've literally done 2 steps. I've gotten my 2 factors that add to the coefficient of the middle term, which is 10. And now I've got to do my step 3. And here's where things go a little bit tricky. So the original trinomial is 3x squared plus 10x plus 8. What we have to do in this step is we have to break up the 10x into the two values, the two coefficients that we found, 4 and 6. But of course, we've got to keep x with them. So the 10x gets broken up into 6x, positive 6x, and positive 4x, because those are my two values. So I'm decomposing that middle term, and this is why the method is called decomposition, because I'm breaking up the middle term. And you can't tell me that this is lying. I'm really just kind of expanding this and saying 10x is really made up of 6x and 4x, and it's actually going to be quite helpful for me to break it up this way. All right, so now that we're here, now that we have decomposed our middle term, the next step asks us to group these terms together. And you're going to ask me how? Well, we've got 4 terms, right? What we're going to do is group them by 2. So we're going to do first 2 terms and last 2 terms together. The plus must stay in between, okay? So don't mess around with that plus. And I'm going to put my 2 terms into brackets. And I am actually now just having to factor out these these pairs. And I find the GCF between each pair of terms. So what's the GCF, or the greatest common factor, between 3x squared and 6x? So when I'm looking for a GCF, I'm really looking for the largest value that I can divide out. And I hope that you agree that that is 3x. So I'm going to divide both by 3x. Then I look at my second pair of numbers, and I do the exact same thing. I look for a GCF between them, and that's just plus 4. So I'm going to factor out a plus 4. Fantastic. So now that I have factored it out, I can actually write down what I've got left over. So I factored out 3x out of the first group, and then I'm going to put my bracket and write down what is left over. What's left when I've divided 3x squared by 3x? And I hope that you agree that the 3 is gone. 3 divided by 3 is 1. And then x squared divided by x to the exponent 1, or just x, is really just x. Plus 6x divided by 3x, well, the x is gone because I've divided it out. And then 6 divided by 3 is 2. In the next group, or pair of numbers, I've got plus 4 that I'm factoring out. So you've got to write that out. Plus 4 is what you have factored out. And then again, a bracket of what the leftover is. And the leftover I figure out through division. So 4x divided by 4 is just 1x. 8 divided by 4 is just 2. So positive 2. There we go. And you will always, always, always come up with this. So this is a really cool, if you notice that this x plus 2 and x plus 2 is common to this expression. So what do we do here? So we've got x plus 2 that is the same, and that's what we're going to factor out. So we're essentially going to take out x plus 2, which is the greatest common factor between these guys. We're going to factor it out. And what does that mean that we're going to end up with? So we're going to end up with x plus 2 because we just factored it out. So here it's going to be gone, but of course we've got to write it in our final expression. And then the second bracket will be a leftover. And what's left over when I divide each of these terms by x plus 2? Well, for the first part, I'm going to have 3x. And then the next part, I'm going to have plus 4. So that's my 3x plus 4.